There. Okay, so all of you in the 9th grade learned everything you needed to know about exponents. The problem with it is, unless you are in my class, I cannot guarantee that your teacher went one step further than he or she needed to go, so you would be able to do this stuff easily. Okay? If you were in my class, I said, I don't care what the curriculum is, I'm going to teach you one step more so your life will be easier next year. Why? Because I am Grinchy and my heart is 2 sizes too big. If you are not in my grade 9 class, which in this room there are a few of you, sorry, but you'll get it today. Okay? But first, review. 7 to the 3rd power. What does that actually mean? Do not tell me the value. Tell me what that notation means, Vanessa. It means 7 times 7 times 7. Now, at least once in this room, in this unit, somebody is going to tell me that that is 21. They will. It's okay. The person that will probably do it is B-Rad, because he does it, and Mikey. They did it all the time. They know what it means, but you automatically want to say 7 times 3, 21. And that's okay. I will just mock you. All right? Okay. So we know this is not 21. This is, in fact, 343. Right? Everybody remembers this, correct? Everyone is Gouda? No one is Swiss? All right, so next thing we're going to talk about is what are the parts of this, all right? So the first thing I'm going to do is highlight in yellow that big 7. That is the base. Now, I am not going to give a definition of the base because you already know what the definition of the base is. It is the thing that is repeatedly multiplied. I'm not going to write that down. Your eyes can see that. What I am going to write down is this, because this is where kids go wrong. The base is whatever. Does that mean it can be a number? Yes. Does that mean it can be a letter? Yes. Does that mean it can be a symbol? Yes. Does that mean it can be a blank box? Yes. Whatever is written directly left of the exponent. Please highlight directly left. Okay? Here is what I mean. 7 cubed. What's the base? 7. Negative 7 cubed. What's the base? 7. Negative 7 cubed. What's the base? Negative 7. Does everybody remember this from the 9th grade? Okay? The brackets mean the negative is part of the base. When there are no brackets, the negative is not part of the base. Everyone remembers this? Okay. The exponent. Again, I'm not going to tell you what it is because you already know that. Okay? What I am going to do is tell you what it is called. The exponent is the superscript, which is the proper word for it. The little number up and right of base. Can it be anything? Yes, it can. In grade 9, it was always a natural number, wasn't it? It was always it was always a whole number. It was 0 up to infinity with no fractions and no decimals, yes? Okay. Everyone's cool with it? All right. The power is the base and exponent, and we read it as base to the exponent. So in this case, 7 to the third. Okay? What are the only two that have special names?
First, second, and...
Not even the first.
Oh, yeah, second and third.
x2, which is squared, and x3, which is cubed. Everything else has, you say it this way, base to the whatever it is, 4th, 5th, 6th, 7th, 11th, 27th, 32nd. Cool? Okay. Now, you guys already know from the 9th grade how to fill in this whole chart. All right? Yes. Go. I'm going to be filling it in up here, and then I'll show you all the right answers. Whatever you need. You will obviously need your calculators to do a couple of them. That is okay. You are more than welcome to. There's only one thing there that you have not previously been taught. But you should be able to figure out. And there are the correct answers. In a moment. Connect. Okay, you shouldn't have had any questions about any of them except possibly that one, and that one. Is everybody okay with why all of them are what they are? Does anybody need anything from this page more explained to them? This is all except for the x cubed grade 9 exponent. Brad. Okay, negative 4 is in brackets. So the negative 4 has to go again and again and again and again and again. That gets you positive 4,096. Because negative times a negative is positive, times a negative is negative, times a negative is positive, negative, positive, yes? But there's a negative out in front. That negative sign means everything after it, no matter what, is negative. Okay? So if you punch negative 4 to the 6th into your calculator and you punch it in properly, you get positive 4,096. But the negative number in front makes it negative. Okay? Everyone is good? Everybody remembers this? Yes? Okay. In grade 9, you made a lot of use of this button on your calculator. Or it might have been y to the x, or it might have been x to the blank. In grade 10, you will almost never touch those buttons. Because in grade 9, you only dealt with numbers, yes? So you could always use your calculator to find what those numbers equaled, right? In grade 10, you are dealing with variables. And you cannot tell me what x cubed is, can you? Because you don't know what x is. So your calculator is not going to help you. Does everybody understand? All right. Now the first thing we're going to do is we're going to review the 5 things that you already know. Okay? But we're going to add the grade 10 wrinkle to it. If you were in my grade 9 class, you already have seen this. So, in grade 9, multiplying powers of the same base. 2 squared times 2 cubed. Do not tell me the answer, because I can train a monkey to tell me the answer. Tell me what this means. 2 times 2, that's the first thing you did, times 2 times 2 times 2. Now, if we know one thing about math, guys, what do we know? They're lazy, and they're not going to write that. So what did they invent to shorten it down? Exponents. That is 2 multiplied by itself 5 times. What is the rule? Now tell me what you do here. They're the same base, you add them. That's what we did in grade 9, right? And if you're in my grade 9 class, I wrote it out like this because I knew that's what grade 10 was going to do to you. X to the y. Actually, I'm not going to use y's because I'm going to use a's and b's because there's a reason. X to the a times x to the b is what?
X A B.
A plus b. You must say plus. Does everybody remember that? Did the base change? X, X, X. Did the base change? No. Only the exponent changes. Okay? Is there anybody that has not seen this before written with letters? Oh, thank goodness. All right. Dividing. 2 cubed divided by 2 squared. What does it really mean? 2 times 2 times 2 over 2 times 2. What do you get to do with anything that's the same on the top and bottom of a fraction? Cancel it. 1, 2. Leaving me with 2 to the first. Right?
And if there's like 1.
Also known as 2, of course. What is this as an actual rule? X to the A over X to the B equals X to the A minus B. We all remember this, yes? Not news to anyone. In grade 9, the most we would ever ask you to do is 2 of these in each question, yes? 2 laws, maybe. In grade 10, questions can use all of them. Okay? Okay, this one caused trouble in the 9th grade. I don't really know why, but it does. Raising an exponent to an exponent. Okay? 2 squared cubed. What does that mean? 2 squared. How many times? Thrice. And what does that mean? 2 times 2. 2 times 2. 2 times 2. Which gets me 2 to the 6th. What's the shortcut? Multiply. So X to the A to the B equals X to the A times B. Everybody remembers this, yes? Yes? Okay. Now, you guys should have a bunch of blank space right now, yes? Perfect. That's why you proved to me that you remember this stuff. What is A squared times A cubed? A to the 5th. Lovely. Well done. Mikey, you can now not answer a question. Okay? Everybody ready? What is X to the 3rd times X squared Y? Mikey, you can't answer. Alicia. X to the 5th Y. Very well done. What is X squared to the 9th? No, Alicia, you already did one. Now, Joe. X squared times 9, which is? X to the 18th. Everyone's cool? If you're lying, you're dying. Everyone's cool? Okay. X to the 4th, Y to the 6th, over X2, Y2. No! No!
Can I do it?
Yes.
Oh, it's X2, Y4.
X2, Y to the 4th. Is everybody good with the first 3 laws? Okay. You guys should be on your next page now, yes? Yeah. Everyone is okay with that? Okay, now, if you look on your outline, you will see that we have covered basic exponent rules, yes? And I'm supposed to give you a worksheet right now, but I'm going to trust you're all in good shape. Okay? Because what I would like to do is give you everything today, because you're writing a test tomorrow, and it probably won't take the whole period, and then we can work on our work for the rest of today and tomorrow. Is everybody okay with that? All right. So we're going to keep going with notes, even though right now I should be giving you a worksheet. But we're all good, yeah? Okay. Oops. So you should now be looking at this sheet, yeah? Okay. A fraction base with an exponent. 2/3 squared. What does that mean? 2/3 times 2/3, which is 4/9. Right? It is also, thinking back to the law we just had, isn't this 2 going over brackets? So it goes to both of them. 2 squared over 3 squared. Everybody cool with that? So what would the rule be? X over y all to the a. What does that get me? X to the a over y to the a. Everyone good? Now, can I forget about all the other laws here? No. If this is going over a bracket, it still has to multiply by anything that might be in here, yeah? Okay. An exponent of 0. Now, the exponent 0 causes a lot of people a lot of problems because a great many of you haven't been shown why it is true. You have been told what the answer is. What is 2 to the 0? 1. Okay? What is negative 2 to the 0? Negative 1. What is negative 2 to the 0? Positive 1. The reason this confuses people is because you memorize this. Anything to the 0 is 1. That's all you hear. You don't take the time to learn why. So I'm going to show you why. Then it will help you in the future. 2 cubed over 2 cubed. According to our exponent laws, what should I do with those exponents? Subtract them. So that should be 2 to the 3 minus 3, correct? Which is 2 to the 0. Everybody cool? Great. What is 2 cubed? 2 times 2 times 2. 2 times 2 times 2. Over. What is 2 cubed? 2 times 2 times 2. Which is 8 over 8. What is 8 divided by 8? 1. So if this equals this, which equals this, which equals this, and it equals this, which equals this, then what do we know about these two? They are equal as well. That is why it works. Okay? Everybody cool? Picking up what putting down? Read my mail, mow my lawn? Okay. Now, everybody take a deep breath. Hold it. and cleanse. Because we're about to do something totally new and alien to you. It makes no sense at all unless you understand everything we have already done. Okay? It is negative exponents. So I'm going to write here something, a base and a negative exponent. 2 to the negative 3. Does that construction make any kind of mathematical sense? The people that are not allowed to speak right now are Peter, Felix, Bradley, and Bryce.
Well, maybe it's because we multiply 2 by the same, but not the same because
That's why it makes no sense, right, Mikey? Because 2 to the 3 makes perfect sense. 2 times 2 times 2, right? Negative 2 to the 3 makes perfect sense. Negative 2 times negative 2 times negative 2, right? But this is 2 to the negative 3, which makes no sense at all, does it? How do you write the base 2 negative 3 times? Alicia? Pardon? But then it would be, then the negative would be down here with the base. The negative is up with the exponent, isn't it? So this makes no sense. Does everybody agree? All right. So since it makes no sense, math guys had to come up with why it makes sense. Because it does indeed make sense. Okay? Here's how it works. 2 to the 5th divided by 2 to the 8th. Is everyone cool with that? Okay. According to our exponent laws, what do? I do 2 to the 5 minus 8, correct? Which is 2 to the negative 3. Makes sense, right? We're following our exponent laws. The problem is, this final answer makes no sense in math, does it? Unless you know what is actually happening. What is 2 to the 5th? How do I write that properly? 2 times 2 times 2 times 2 times 2. Correct? And then how do I write 2 to the 8th? 2 times 2 times 2 times 2 times 2. And then what? 3 more. Does everyone agree? What do I get to do with these 2's? What do I get to do with these 2's? These. What is left? 2 to the 3 on the bottom of a fraction, correct? Now, you have to actually understand math. There is no number written here. Division is related to what other math operation? Multiplication. In multiplying, Vanessa, what is the number that we never ever write? 1. Right? What does that mean? That means 1 times x, doesn't it? But we never write 1. Agreed? This is not 0x, because 0x would be what? 0. This is 1x, correct? So what number must live here? 1. Because if it's 0 divided by something, then the answer is 0, isn't it? And we can quite plainly see that this is not 0. Right? So, please look. If this equals this, which equals this, which equals this, and this equals this, which equals this, which equals this, what do we know about these two things? What are they? They are equal. Does everybody follow the logic? Now, since none of you care about why things happen, let me show you what it means for you. X to the negative a, because negative exponents make no sense, is the same as 1 over x to the positive a. All you do is move the base to the denominator and make the exponent positive. Is everybody good? Now, of course, that opens us up to other situations, doesn't it? What if I have this? 1 over x to the negative a. Now there's a negative a that makes no sense, isn't there? Where is he? He's already in the denominator. Well, when he was in the numerator, because this is really x over 1, isn't it? He went to the denominator. What happens here? Where does he go? Where? Back to the top. So this becomes x to the positive a, and it changes. Is everyone cool with that? Yeah? Because we remember, a negative exponent makes no sense, yes? So now, the final one. These two people I have very little trouble with. The next thing I'm going to write, for some reason, kids can't figure it out. X to the negative a over y to the negative b. Do negative exponents make sense? Are they allowed? No. So where does the x with the negative a that is up top go? To the bottom, and what becomes of its negative? It becomes positive. Where does the guy on the bottom go? To the top, and what becomes of his negative exponent? That, for some reason,
Isn't that kind of like algebra?
it is algebra.
No, I know, but like, divided?
Oh, do the opposite of what you see.
Yeah.
Yeah.
Okay.
Is everyone cool with that? This is new. You have not seen this in the 9th grade unless you had a teacher that really, really cared. Okay? Anyone that was in my class saw it once, and I told them, now you don't have to worry about it until grade 10. So forget about it, but you've seen it. For some of you, that was closer than you thought. Because here it is 6 weeks later, and you're seeing it. But you did know it. Everybody cool? Right. Did she show you this in the 9th grade? Well, she may very well be. But if she had a class that was not able to fathom that or needed all the time to get the regular stuff, then there wouldn't have been time to show her new stuff. All right. That's the first new thing. Put a little star by it, because that's new.
I learned that last year.
Good. Now, number 4 is old, isn't it? I've gone back to the old, haven't I? Because right now you're like, but this one you already know. Right? This one in grade 9 had 2 things, 2 ways to show you. Okay? In grade 9, this is the 2 ways we wrote it. 2 times 5 squared. You either wrote it this way. The 2 went to everything inside. So you got 2 squared times 5 squared, yes? What is 2 squared? 4. What is 5 squared? What is 5 times 25? 100. 4 times 25. I said 5 times 25, didn't I?
I just assumed you guys said.
Right? Cool? And the other way we did it in grade 9 was this. We did 2 times 5, didn't we? 2 times 5 squared became 10 squared, which became 100. Right? And in grade 9, we could always do that, couldn't we? Because we were always using numbers. But in grade 10, sometimes we use letters, yes? So xy to the a becomes xay. Is everybody good with that? Yes? All right. That, for you guys, is where I wish to stop today. Okay? So we're going to draw a little line. And I'm going to get you the sheets that you need to do. That is these two worksheets, Lesson 5 and Lesson 6. Listen to me and listen to me closely. You're going to work on them today. If you don't get them done, I do not